Hello guys, welcome to the discussion of the few GMAT questions that you have sent me. This is Ankur Rupani. I've been GRE GMAT SAT coach for several years now, and I love this test. I hope as we go through this discussion, you will fall in love with this test as well. It's very important to start enjoying this kind of questions, and as soon as you start enjoying it, you'll find your score starts going up as well. And also to enjoy it, first we have to develop understanding. The test is extremely concept intensive. You've got to know your concepts very well, and then GMAT takes the next step and tests your application of those concepts. So let's take a look at one question, and it will give you a very good idea of what I just said, how the test is testing you on concepts and then its application. So let's take a look at this first question. T equal to $6.8 AB8 if A and B denote the hundredth and the thousandth digits respectively of the sum of money T. What are the values of A and B? Statement 1, if T was rounded to the nearest cent, the result would be $6.85, and statement 2, if T was rounded to the nearest tenth of a cent, the result would be $6.85. Great. So now as you have seen, there are a lot of concepts involved in this question. You've got to know of what is this 100th digit, what is a 1000th digit, right? We've got to know what does this mean, rounding to the nearest cent. We've got to know what does rounding to the nearest tenth of a cent mean. So these are your concepts, and then we'll come to its application. So, but first let's just go through the basic concepts. So let's take a look at this and just refresh our memory. 213.245, let's say as an example, what would be the digit which is in the 10th place? Now you may recollect that the 10th place is nothing but the digit to the right of the decimal, immediate right, and hence the 10th place is 2. What is the 100th place digit? It is the digit to the right of the 10th place, and therefore it is now the digit 4. The 1000th place is the digit to its right, which is 5. Great. Units place, the digit before the decimal, it is 3. Tens place, the digit before that, which in this case is 1. And hundreds place, the digit before that, in this case it is 2. Great. So I think that makes the concept of digits, the position of the digits clear. 10th place, 100th place. A few things to notice and keep in mind. Here it is ending with TH, here it's ending with TH, here it's ending with TH. So you know now that if we are talking about 10th, 100th, 1000th, we are talking of the digits to the right of the decimal. And here you notice we have S, S, S. So we know now that if we are talking about the units, tens, hundreds, we are talking about the places before the decimal. Also, one more thing to notice is that there is a units place, but there is no unit place. Okay. The decimal digit after the decimal is 10th and not the unit place, because 10th is defined as 1 by 10. So obviously the first place itself is the 10th place after the decimal. Okay, so these are a few key observations to make as far as this concept is concerned. Great, let's move on to the concept of rounding. Now again, you may recollect the rounding principle is basically the concept that if we are rounding a digit, we look to its right, and if the digit is 5 or more, we round the digit up, and if the digit to the right is less than 5, we leave it as it is. So let's take an example here. We have 123.235 and we are going to round it to the 10th. Now as we've discussed earlier, 10th is the decimal, the digit after the decimal, that is 2. Now, if we are rounding it to 10th place, means this digit has to be rounded to this place. Now, look at the digit to its right. It is 3. And therefore, since it is less than 5, we will not round it up. And hence, your answer will be 123.2. Okay. Let's take a look at the next one. Rounding to 100th place. 100th means this digit. Okay. So, we are going to round this. Now look at the digit to its right. It is 5, and as the rule says, we're gonna round this up. So 123.24. Great. So I think this would again have clarified and refreshed your memory as far as the rounding principle is concerned. So let's try out the following. What would 125.354 be if it was rounded to the nearest 10th place? So apply the concept. Let's see if you got the answer. I'll give you a second. Okay, great. So hopefully you got the answer. Let's see. I'm gonna type it out. 125 point. We are rounding it to the 10th place. 10th place. Okay, let's go to the 10th. Look at the digit to its right. It is 5. Hence, we're gonna round it up. So answer is 125.4. Awesome. Next one. What would 123.354 be if it is rounded to the 100th? Alright, so 100th place, let's go. 100th place is 5. Look at the digit to its right. It is 4. Hence, what we are going to do is not round it up and leave the answer as it is, 125.35. Great, so hopefully that has clarified the concept of rounding. Now we are armed to tackle this problem. Alright, great. Let's see the problem. Okay. Oh wait, sorry. We have one more concept. Concept of rounding to cent and nearest tenth of a cent. Okay. As we've seen, the two statements have these words. Let's see. Rounding to cent means that we are rounding to the 100th place. Alright. So why? Because 100 cents make a dollar, and so when we are rounding to cent, we are rounding it to the 100th place. So let's take an example. Suppose I say dollar 432.245, and we were rounding it to the cent. Cent means the 100th place. Go to the 100. Look at the digit to its right. It is 5, and hence this would be rounded off to 432.2 and 5, because the digit to its right is 5. We're going to round it up. Awesome. Now, next one, rounding to nearest tenth of a cent. Tenth of a cent means 1/10 of a cent. Now, obviously, since rounding to cent, we are rounding it to 100. The nearest tenth of a cent, we will do 1/10 of 100, and hence we will round it off to the 1000th place. Great. So let's take an example here. Again, 1.2345 rounding to cent will become how much? Alright, apply the principle and let's see if you got the answer. We are rounding it to cent, which means it is rounding to the 100th. Alright, so dollar 1.2, and then we have 3, next to it is 4, so we're gonna round it as it is to 3, and that's your answer. And what about this one? 1.2345 rounded to 10th of a cent. Alright, so 10th of a cent means rounding to the 1000th place. Alright, so round it off to the 1000th. Let's see, 1 point, this is your 10th, 100th and 1000. Look to its right, it is 5, so it has to be rounded up, right? So 2, 3, 5 is your answer. Alright, great. So hope you got those concepts. Now we are actually armed for the question. Let's see. Let's tackle it. Statement 1 says that $6.8 ABA rounded to the nearest cent would be $6.85. Alright, so let's apply the concept. We are having this number here, 6.8 ABA. We are rounding it to, as we've discussed, nearest cent means that we are going to round it to the 100th place. 100th. So let's go to the 100 digit. It is A. Next to it is B. Alright, so we would round A up if B was more than 5. Otherwise, we would leave A as it is, but we don't know B. So we have two scenarios. One scenario is B is greater than or equal to 5, in which case I would round A up, and A after rounding becomes 5, hence originally A would be 4. Alright, but the second scenario, what is the second scenario? B is less than 5. If B is less than 5, then we do not round A up. Without rounding it up, A becomes 5, hence originally also it is 5, and therefore we have two answers. We have A is 4 and we have A is 5. In fact, B we do not even know because there is no information about B. B could be any number, any digit. It could be greater than or equal to 5, or it could be less than 5. Hence, we do not have a definite answer, and therefore statement 1 is not sufficient to answer this question. You might recollect that a statement is sufficient only if we get one definite answer, and therefore this statement is not sufficient to answer the question. Great. So just a quick recap. Alright, so statement 1 says that it is rounded, 6.888 rounded to the nearest cent would be 6.85. Alright, so we say 6.888 rounded to the 100th place, because we are rounding it to the nearest cent, is 6.85. Go to the 100 digit. 100 digit is A. Look to its right, it's B. We don't know about B, so we consider two cases. First case, B greater than or equal to 5, in which case A would be 4, because it would be rounded up to 5. Second case, B less than 5, in which case A would be 5 itself, because it is not rounded up, and we would leave it as it is. Then we get two answers for A, no answer for B at all. Therefore, statement 1 is not sufficient. Awesome. Right. Now let's see statement 2. Statement 2 says, if $6.888 was rounded to the nearest tenth of a cent, right? So let's underline that. Right. The result would be what? 6.85. Now notice that the question said 6.85, but I'm going to put a 0 there. Why? Because we are rounding it to the tenth of a cent. We know that that means 1,000, and the 1,000 digit is 0. And now let's look at the interpretation. 6.888 rounded to the 1,000th place, right? Because nearest tenth of a cent means the 1,000 digit, 1,000th place, alright, will become 6.850. Like I said, we add the 0 because we are looking at the 1,000 digits. So now go to the 1,000 digit here, 10th, then your 100th, and then your 1,000. Now, very interesting. Next to it is 8, right? So that means B has to be rounded up. But after rounding it up, it is becoming 0. What does that mean? What does that mean? Does it mean that B originally was -1? It's not possible, right? So now you have to think a little bit, right? So B must be 9, because when I round B up, that is when I round 9 up, it will become 10. 0 will be in that place, and what will happen to 1? 1 will get carried over, and 1 will come into this place, and you will have 1 adding with A, and 1 added with A becomes 5. Right? So A plus 1 equal to 5, which gives me A equal to 4. Alright, and we said B has to be 9, because only then the rounding up will result in 10, giving me a 0 in that place. Great, so now do we have an answer? We have A is 4. We don't have any other option, right? And we have B equal to 9. Again, there is no other option, right? Hence, we are giving one definite answer to the required question, and therefore we can say that the statement 2 is sufficient to answer this question. Awesome. So looks like we've got the answer. Quickly recap. 6.888 rounded to nearest tenth of a cent. Then tenth of a cent means the 1,000th place. Alright, look at the 1,000th place. Initially nothing was given. We put a 0. So 1,000th place is 0. Look at the 1,000 digit here. It is B. Look to its right, it is 8. So we now know that B will be rounded up, and it will become 0. 0 means B was 9. Alright, and it was rounded up to 10. Now 0 is left, and the 1 gets carried over to A, and A plus 1 becomes 5, which results in A to be 4. We get B equal to 9, hence a definite answer. Statement 2 is sufficient. And this leads us to our answer. 1 is not sufficient, 2 is sufficient. We can say therefore that the answer is B, because B is the choice, which is one statement is not sufficient and statement 2 is sufficient. Awesome. So hopefully you got this. Let's just tackle one slightly different question. We can create a what if scenario here. What if the second statement said that 6.888 rounded to the nearest tenth of a cent is 6.852? Alright, so tenth of a cent means the 1,000th place. Look at that. Next to it is 8, and that means we are going to round b up, and b rounded up becomes 2.